This video on the Resources on Proof series is about proof by induction. Proof by induction is used whenever you want to prove a statement for every natural number. Here we've got a prime example. For every n in the natural numbers, n has property p. To use proof by induction, you first prove that 0 has property p, and then if you add to your assumptions that n has property p, you want to conclude that n plus 1 has property p. As I've mentioned before, this is used whenever you want to prove something about every natural number. However, sometimes proof by induction is used when there isn't an obvious candidate for the natural number that you're doing induction on. In a lot of statements, the n is hidden. So let's look at an example of a theorem that you can prove by proof by induction. This is a prime candidate for proof by induction. Here we have the sum from I equals 1 to n of I is equal to a half times n plus 1. As I mentioned before, this is a prime candidate because the n is right there for us to look at. Let's start with the base case, the case when n equals 1. Now earlier I mentioned that you look at 0, but in this case the situation when n is 0 doesn't make much sense. So instead we start with n equals 1. Here we see some calculations that show that it's obviously true. Now let's go on to the inductive step. So we assume that the statement is true for some arbitrary natural number k. So we're assuming that that sum is true for n equals k, and now we want to deduce that the sum is true for k plus 1. So here we've got some numerical manipulation which deduces the conclusion for k plus 1. So now that we have both the base case and the inductive step, we can put them together and conclude that by induction for every natural number n, sum from 1 to n is equal to a half times n plus 1. There's a written version of what you've just heard if you prefer to learn that way, and we also have videos and written resources about the other types of proof. Thank you.